Three, two, one. Good evening, everyone, and welcome to another episode of Go Time.
Or good morning. Or good afternoon.
Let's do it. It's go time.
Did we go
So,
live on the tubes?
we are live on the tubes, and welcome everyone from whatever hour of the day you are joining us. Whenever you're hearing this live or recorded. I think for once this is a European majority here, so we can say good evening. And I am joined today by my co-host Johnny, and we have two guests, and we have Anthony and we have Smile. Anthony, you are a senior software engineer at Delivery Hero here in Berlin, and you've been working with Go since 2013, and you're a co-founder of API Toolkit. And Smile is your co-founder, and you are a senior mobile engineer at Rantastic, and you also work with Go since about 2015. Welcome, it's nice to have you.
Thanks for having us, Natalie.
Okay, so what does API stand for? Let's ask you the questions first.
Huge question. No pressure.
No pressure. I had to Google that before coming to the episode. So if anybody who's listening, Googling right now, it's we get you.
So, I mean, an API is an application programming interface, but I think it can mean a lot of things. But I like to think of an API as a contract. So if you have, for example, two services, two machines, one server and one mobile application, and they need to communicate with each other, both parties can decide on this contract on, if I ask for this, this is what you give to me. If I ask for this other thing, you give me this other thing. And that contract is basically what I think is an API.
Okay. Smile, what is your take on what is an API?
My take on what an API is roughly the same thing. And coming majorly from the mobile background, I would always say an API is more or less a series of endpoints that would give you resources.
A series of endpoints that will give you resources. That's like short and to the point.
That's I like those definitions. They're very specific and sort so in terms of use, right? That's one way to use an API, right? Maybe you're making some HTTP requests. Maybe you're dealing with a different transport mechanism. Maybe you're doing it through gRPC. Maybe you're doing if you might perhaps fortunate or unfortunate, maybe you're dealing with some SOAP APIs.
Hopefully not.
Hey, a lot of people still make a living on it, so I'm not knocking it. But these are, to me, these are sort of ways. How do you communicate, right, with an API? To me, an API is as the name implies, right, application programming interface. It's the interface to your functionality, to your code, right, to the behavior that you've produced and created, and perhaps it's not exposed over the web, right? Maybe you don't talk to some sort of HTTP endpoint to invoke the API or do things with the API. It could be as little as me creating a package in Go and basically saying, okay, what is the surface area that I'm going to allow somebody to interact with? What is that? What is the API to this package, right? And you control that through the things you export out of your package and the things you choose not to export, right? What is internal to your API and what is external? What do users of your code get to actually use? So that surface area, to me, at its most basic, is how do you interact with something, whatever that thing is. And obviously I'm using Go packages here as sort of the way to sort of convey that. But to me, that's that sort of at the core of it. That's what that is.
Yeah.
Even if you have like a code base, maybe just like a library or a Go package like you mentioned with a series of exposed functions. Those exposed functions are also part of the API.
Mhm. So and when building, right, the API toolkit project, now I'm very curious about what the sort of the company is basically what the offering is. With the name like API toolkit, it sounds like you're sort of bringing something generic in the sense of something that is a general purpose rather for APIs. Do I get that about it right? Like what is it that you're bringing to the game here?
I mean, the two most difficult problems in computer science, and naming things and, and the rest. Yeah, finding names is hard, but I think this name kind of sums up a lot of what we're trying to do. We're trying to solve a few problems around APIs, and the name kind of gives it room to grow. The main problems that API Toolkit is trying to solve is around anomaly detection. So you have an API, in this case, primarily RESTful APIs, or APIs that you expose over a transport. But let's stick with the REST API. So you have a REST API with a series of endpoints, and each endpoint returns a series of fields with values, and something changes. For example, you have maybe a new engineer on the team who makes a change, and that change snowballs and just touches something else. Sometimes this kind of changes can be difficult to spot, or even, there are other things that could happen. For example, you have a legacy service which you're trying to rewrite for different reasons, and you believe you know about the contract of that API because it was very well documented. But then you rewrite that API and realize that, okay, there were some fields which were there maybe 10 years ago. No one knows about them anymore, but they are part of this contract and you did not know about them. And so something breaks. So API Toolkit tries to find these issues before hopefully your customers find them.
Mhm. So that's an interesting problem space. So if we can start to sort of dig in a little bit here, so when I think of sort of the operability, right, of an API, right? Say, you make something public, and once you make it public, like you said, you have a contract, right, with whoever's going to be consuming that. So making changes to that API is very hard to do, right, after you've published it, right, after you have a V1. Hence why you typically have to have some strategy for how you're going to move customers onto the next version of whatever it is, right? So the use case you give is one where maybe you have some less traveled parts of an API, and all of a sudden you think, okay, maybe I can or can I not change this or make some modification, tweaks, whatever it is, maybe even make some backwards incompatible changes. So what you're saying is that you want to have enough information about sort of the usage, how the API is used, right, in order to know what is the likelihood of me making a change and breaking a particular endpoint, right, in the sort of set of endpoints. Do I get that right?
Very much, of course, within the limits of what a machine can figure out, learn about your service. It tries to understand these are the fields that are usually being sent. This is the frequency which they're being sent. This particular field, this name is usually, maybe it's a string, it's a text field, and it usually has this kind of format, this kind of mask. Maybe there's some alphanumeric mask, and then there's a space and another mask. So if someone changes that name field and starts to return numbers, then obviously something is wrong. You want to ring a lot of bells and let people know, hey, this used to be a text field with this format, and now it's returning numbers. So
okay, I'm sorry. Okay, I see. So is this development time tool. So this is you want this detection before going live with an update with a change,
Yeah,
right?
in production, in real time, live.
So
I mean,
before you go to production, right? Or when are you detecting? When are you saving my bacon? When are you saving my bacon? Like,
I mean, Smile, you wanted to add something first?
ideally, we would all love for this detection to occur before you go to production, and definitely the tool would surely run both on your staging server and your production servers you would have. But it all depends on the tool itself detecting these anomalies. So if you have this running on your staging environment and you've probably run tests like integration tests within your staging environment, most likely the toolkit would be able to detect such things. But if you're like maybe one of the cow persons who will probably push straight to master and deploy, like in a rodeo, then of course these kind of things will be detected on production.
I
But
mean,
that's the worst case scenario.
in a perfect world, a tool like this probably should not exist, because if people were building perfect systems, well tested, every single endpoint is tested, every single field is tested. I mean,
And
your
everybody's
test
following your
pass-
updates.
yeah, then you really don't need something like this. But unfortunately, in the real world, we always make compromises. People deploy to production on a Friday night, and we want to catch issues. And the issues don't only come from within. So you have a service. The issue might not be that in on the service side things are broken. The issue could also be that on the consumer side something is broken. For example, if a consumer used to send a particular format of input, and someone deployed a web app or a mobile app that starts sending something else, then we also want to flag that and notify someone that, hey, this server is accepting a very different input from its clients. And the clients could be third parties, could be other companies who don't have those best practices that you are following.
I have
okay,
to
so
say that. Sorry.
Oh, I was
Yeah.
about to say there was something that came up a lot during our interviews where it's actually based on third parties. We integrated a third, and one of the things, yeah, I think it's also a bad practice when you version an API and you end up going back to version 1 and changing things. Meanwhile, we know if you are going to be using API versioning, if you move to version 2, you're not supposed to go back to version 1 and introduce new changes. But you constantly see third parties doing these kind of things. We won't name names, but this kind of things have come up a lot within our interviews where you would integrate a third party, usually within payments, and you wake up some weekend or a Monday and you see a lot of requests are broken, things are not going through. And why? Because someone somewhere or some machine somewhere changed the version, old version, and added new fields and changed old fields which shouldn't be there. So now it's not even about you making a mistake. It's more like a API you consume is breaking the contract that's been set. And in things within these kind of situations, you definitely want to get an alert about something like this so you could mitigate such effects.
Well, I actually just remembered a conversation we had in the interviews with someone, and he said that they have a popular fintech provider that they consume, that they make use of, and this fintech provider probably deployed a change, and everything was broken for about a couple hours. So they lost a lot of money, but of course the fintech providers probably detected it and rolled back. But there was no public update. They did not say they did anything that broke anything, and they would not agree that that they made any changes which broke things. And I mean, if you have something that shows you and says, hey, this contract broke at this time and this is what changed, you can show and say, hey, you definitely broke something, and this is what you broke at this time.
So it's interesting that you're actually, before I ask my next question, Natalie, I know you were about to say something. I wanna make room.
Yeah. I was first time that we talked about API toolkit. I kind of imagined myself that a good scenario for me to use that would be as a consumer of different APIs. But just now, you all mentioned that this can be a great tool also for the provider of APIs to make sure that you all are in sync. So that's a very interesting like accountability tool in addition to everything.
Definitely.
So along those lines, right? So it sounds like, and we're gonna get to where Go fits into all this in a bit here. So I want to make sure I understand your project before we dive in deeper. So your website, APIToolkit.io, mentions observability. So observability means something very, I think, very specific these days, right? It's no longer just monitoring, right? So observability implies other things. And obviously, we talked about sort of the accountability here. So I'm sure if you consume, let's imagine that I consume an API, right, from a fintech company, right? And we have an SLA, right? There's a service agreement that says I can expect, this throughput. I can expect, this is when I should, if at all, expect outages, et cetera, right? So there's an SLA. There's a legally binding document that says this is the level of service I'm going to get. And then you have tools, right? Whether it be on the provider side or the client side, which obviously APIToolkit.io could be, right, something that you as a consumer, or me as a buyer, right, the consumer of this API, could use to basically create my own SLOs, right, around sort of the availability, right, of this API that I'm paying for and I'm consuming, right? So what does observability look like for this project? Like, are you providing tools to track over time? Like, what the performance is? Like, what kind of information are you surfacing with those with each sort of tracking that you're doing?
It's funny that you say observability is very specific these days. I actually think of observability as a word. It's just people are using it to mean so many different things. Probably API Toolkit is, joining that list. But when we say observability in the API Toolkit context, we actually mean what the word says. It's a tool that allows you observe both your API, but also clients and requests which are coming in, and third parties that you call. Monitor them down to the field level, so you can see each single field. You can see how often each field gets sent or gets received. But you can see this information over time, like you said. So you can see that, the obvious API statistics, for example, that 20% of your requests to a particular endpoint end at a 404 error. But you can also see that the name field in these endpoints is a null, let's say 10% of the time, and that's something you want to fix. But you can go down to the over time and see a lot of these statistics over a period of time.
So
that's what we mean.
Is your focus on the shape of API requests and responses? Like we've come back to sort of the field and the endpoints like a few times. I want to make sure that when we talk about sort of observability, we're sort of localizing sort of the word. We're contextualizing just the basically the shape of the API, less so things like throughput and how long is the average response taking to come back and things like that, or does your solution sort of cover that too?
Yes, I mean, we give you that your throughput, response time, different percentiles. That's kind of like just cherry on the cake. It's nice. We have the information, so why not give it? But the exciting part of API Toolkit is that you get you get these statistics, but down to the level of the fields and the endpoints.
Mm-hmm.
You can pick if you have for example a fintech endpoint where you can accept payments, you
Mm-hmm.
can see that something that we're exploring is that you can see that there's an amount field which usually gets sent. You can see that this field is always being sent on this endpoint. But something we're exploring is that you would even be able to like plot that amount field. So you can on a graph see just basic averages that this field is usually, or over time, that every day the average amount that people transact is $200. But you can just get these statistics down to the level of the fields as well.
Okay.
So we like to just call it field level observability, pretty much.
Okay. Right, but it goes. You have a few layers on top of that in addition to just the field stuff. Okay.
Yeah.
Natalie,
So
what you got before I ask my next question? I know I realize I'm monopolizing all the questions.
No. Go ahead.
All right. So I do want to sort of dig into the Go side of things. What role is Go playing in this product, right? I know you have a lot of sort of plugins and integrations, and Go is obviously one of them. But is Go playing a sort of a bigger role in this project for you?
yeah, Go is, in the development world right now, if you want to do a lot of numbers crunching and process a lot of things in little time, you have a lot of options. But in terms of the popular options, which are also easy to get into, if you're gonna onboard a lot of people on the project, I think Go wins that hands down. It's a relatively simple language to onboard people into, but it's also very performant, and we use Go for a lot of this. We're trying to process our customers' requests real time, and that kind of gives us a very tight constraint, which Go is helping with.
Okay. What are do you can you think of ways that ways that Go has sort of helped you solve a problem that perhaps would have been more difficult with a different language, or even did you even consider any other language? Have you used any other language in this project?
Our stack is actually, we have clients for multiple languages, programming languages, but in terms of the backend side, we mostly have Go and Haskell.
Wow, Go and Haskell. That's an interesting pairing. Tell me more.
Which
Why?
one is the front end?
Yeah, I think a lot of the front end stuff is actually Haskell. We use Haskell for just things where performance doesn't matter so much. But one of the reasons why we really we use Haskell is that for certain kinds of problems, they can be a little bit more precise to represent. For example, we're trying to, you can think of API Toolkit as a kind of parser project, because we get people's requests and we're trying to parse it and understand it. We're looking at the fields. We want to understand what format it is, what types it is. And this is a problem that Haskell historically lends itself nicely for. But a lot of the other things are problems where you just really need to be fast. You need to process really fast. You have constraints, memory constraints. You don't want to have 100 gigabytes memory servers, and that is where Go comes in very nicely. I don't know how the Go team did it with the Go garbage collector, but it's just really hard to beat, and you're able to process a lot of things in very quickly.
So I'm curious where your toolkit lives. Is it are clients routing requests through it for this analytics to be captured, or are you at sort of at the edge at the API gateway level, or where is this deployed?
So there's the ideal scenario, there's the long-term scenario, and there's the now.
Okay.
So, So in the now, what we have are language middleware. So for example, in Golang, you install a middleware. Depending on if you have a web service, you install a middleware for whatever Golang router you use. And what this middleware does is that it basically takes a copy of your request and strips out sensitive information and information which you don't want on someone else's server. And then it sends this copy to our servers to process. And we basically process, you can sample the request, but we basically process every request that we get on the back end to make sure that that request looks like what it looks like what that server was expecting, so that that request actually fits the contract that we have. So it's like a system that is continuously learning. The more requests from a given service we get, the more we understand what that service is supposed to look like. And if something comes which doesn't fit into this our understanding, then we flag an issue and notify someone on that project.
Okay.
Think of it as a lawyer.
Explain more, please.
Explain.
You have two clients, and API Toolkit will seem to be the lawyer. One client doesn't have a lawyer, but the other client has a lawyer, so it's just sitting there in the middle, vetting contracts. So you could think of it that way.
Okay. So I can see that. So I can see how Go in this case would be a good choice as a middleware, as one of your clients, right? So if the sort of shuttling of data on requests happens, every time somebody makes a request, and you Go routine gets launched, and during the processing of the request, hopefully your anything that you're doing in the middleware is not sort of delaying the actual processing of the request. So I imagine you structure it in a way that the impact to the processing of the request, right, because everything has to go through that middleware layer, the impact of for that on the request itself is minimized as much as possible. And then behind the scenes, you're just sending data through to your server.
This is why I told you there's the now, there's the ideal, and there's the future. So for a lot of projects, for example, Golang projects, the middleware approach works very nicely. Where the middleware is part of the project, you can Go's memory representation of information is very compact and quite useful. But if you're making use of a language like PHP, maybe not so much PHP anymore, but a language that tries to be stateless, then such a middleware approach doesn't really work, because you have to send each request to our servers each single time a request comes. Whereas in Go, we kind of, we send everything pretty much to one channel, and buffer. We buffer the inputs from your server and stream them to our servers.
Okay.
In some other languages, language ecosystem, this is much harder to do. So what the plan is to have this kind of sidecars. Actually, we do have the sidecars, but there's just no one using it yet. But the plan is to have this sidecar, which you can, if you have like a Kubernetes cluster or a Docker, cluster, which just, instead of your application sending your request to our server directly, it sends it to this sidecar, which then just pre-processes it and sends it to us. That way, your actual server doesn't need to, it doesn't need to keep a lot of information in memory, or doesn't need to do any processing at all, or little processing.
It sounds very much like sort of the open telemetry community right now. One of the sort of the design approaches is basically to have these collectors, right, that are sort of running, and you could certainly run them as sidecars if you wished. But you can have, if you have dedicated collectors where they're as the name implies, they're collecting all the traces and metrics and whatnot. They on their own time can figure out, basically the sending of whatever data you're collecting to, right, your own servers, right? So you offload that processing out of the application, out of the service, right, into this sort of collector model. So that seems to be a popular approach for this kind of problem solving. So what I'm hearing is that you're hoping that even though Go makes the middleware approach good enough, that's ultimately not sort of the long-term solution, right?
Uh, I'm happy you actually mentioned open telemetry. The entire, I mean, you can think of the information we are getting as traces.
Mm-hmm.
It's basically traces. So the entire system is very much inspired by how open telemetry is designed.
Mm-hmm.
And the collectors are basically language specific. So if you have a Golang server, then you would have a Golang middleware, which can do all of these fancy things I mentioned. But if you're, in a programming, if you have your servers in a programming language that doesn't have those things that makes Go great, then you have to rely on some other approach, like what you see in the open telemetry world. But so for collectors, outside of the collectors on our server side, we use Go is the first line of contact in terms of processing these traces when they come in.
Mm-hmm.
And that's where we actually see the real beauty of Go.
Right. Yeah, right.
You know.
Right. So the problem with the well, I don't say problems, but the whatever subpar performance they might have, in relation to Go, right? You can sort of well, let me rephrase that. I think I'm going to offend somebody. Sorry if your language does not Go. So for certain languages and certain tech stacks, you're going to have sort of optimized for those tech stacks, sort of
Precisely.
collectors and things, right? But pretty much everything that you ship, the moment it touches your network, then it's all Go sort of all the way down, except of course for the Haskell stuff that's sort of doing. This sounded like some sort of abstract syntax tree, like creation or something like that, trying to figure out what the shape of these APIs look like. Okay, so that makes sense.
So talking about API Toolkit, you probably saw a lot of APIs. You probably complained about a lot of APIs in general as you were coming up with the idea for this. So from seeing so many APIs and probably writing a bunch, what are some good practices that you see, that you follow, and what makes them good?
Smart, you want to go first?
So being a mobile developer, I probably consume more than I create. I mean, I don't create so much per se, but one thing that's always hit me, I know this might rupture some feathers or something is, but I feel it's a bad practice. I'll just have to be brave. When you're sending an error and you send an error with an HTTP response code of 200, I take that as like I'm sorry, but it's a really big red flag for me.
Mm-hmm.
I always feel that when you're designing APIs, the error codes are there for a reason.
All right.
If I request a resource, it's not there, give me a 404. If there's a problem on the server, give me one of the 500s, 501, depending on what server it is. If the resource has moved or something, I think it's a 301 or something, but don't give me a 200, then now give me a JSON and tell me error. Then you give me a constructive like error body with another error code. I mean, even when you return like a 400 or whatever, you could return an error body with your custom code if you want that. But let errors be errors. Let response okay be response okay. For me, I think that's one of the worst bad practices. And do I have any other terrible? Oh, okay, yeah. Even when you're returning JSON, returning, it's a small thing. It's a small thing, but it doesn't make sense. If it's a number, let it be a number. But don't put a number inside a string or don't mask a JSON body in a string. It happens a lot. I see it a lot when I'm like communicating with third parties. I get a JSON body within a string, then I have to encode it again into a JSON object before turning it into an actual object. I think for me, those are like one of the pet peeves when you talk within API best practices in relation to mobile development.
I just remembered one issue Smile was ranting about some time ago. I think he spent some time investigating some issue. I think there was a field that if the field doesn't exist would be a null. And he was checking for this null. Maybe you want to tell the story better.
Okay, yeah. So there's this weird third-party provider we have, and when this field doesn't exist, instead they always send a null. They always send a null. But now when the field doesn't exist, I don't know what they do or how they do it. They just don't send the field. And yeah, so when you're now decoding that JSON, it crashes the adapter. And I
you were
couldn't like
telling you were telling me about a situation where they were sending this null, but as a string.
oh yeah, so that's the thing. They fixed it. They fixed it into sending a string, and later on they unfixed it into now sending the null. So like it's a stack of issues. So it seemed like for everything I complained about, they fixed it, and I don't know what really happened on the testing side. I don't know how that kept on passing through, but it kept on changing, and they were like the bane of my existence at some point because I would come into work feeling very happy from the weekend playing game, and boom, there it is. And I had to do so many workarounds because of this, and I just feel things like these are terrible API designs. I mean, most times, ideally, if you are going to send in a value which is a string as a null, that's fine. We could always check that, but removing the field completely, no, that it just makes it hacky. Then bringing it back, and instead of sending a null, you now send it as an empty string. I mean, that could still be worked, but it's just too many inconsistencies.
Yeah, they should be sending like a string to a URL of an image of a meme that says no. Nope.
Yeah. Okay. Yes.
That would make no sense.
Yes, and the part that killed, remember it now. They sent the null as a string. Yes, they sent the null like when you put a null null in a string. So instead of sending null, you send me null as a string. So what happened was
Was there
our
like a
users
dot
were now
after the null? No.
so our users were literally getting null. They were getting null on when you display the text. You were getting null. And I saw these things, and I was like, "How?" I didn't believe I made that kind of mistake, and I couldn't for the life of me understand why I was displaying null. I just couldn't get it. Then when I had to go through the response, when I had to go through the response, I now saw a string null. Okay, that's nice.
That did not live up to your namesake. Did not put a smile on your face.
Oh no, it didn't.
Oh man. So the given that you're probably receiving a lot of your sort of the data you need to process in JSON, correct me if I'm wrong.
Yeah.
How is it dealing with JSON and Go? Do you find like the standard library works just fine, or have you had to use something else?
Actually, yeah, this is one of the hard. So Go actually handles JSON quite nicely. Unfortunately, most programming languages in the world are not written in Go, so this makes it quite difficult to work with. For example, in the non-strongly typed, in the dynamically typed ecosystem, it's very common to have one field that can be three things. Maybe it's an object sometimes, other times it's a string, maybe sometimes it's null, and this is relatively difficult to represent in Go. You need to maybe use an empty interface and kind of go through it. So this problem it kind of makes it harder to consume APIs in Go. It's really nice to produce in Go because every language would get who consumes an API that was made in Go would get something very consistent. But if you as a Go service is the one consuming, then you need to be prepared to deal with these things that are very difficult to represent in Go. And unfortunately, we outsource a lot of these kind of problems to Haskell. Because it's one of the things that the language just exists to solve this kind of parsing problems and it's just more mature in solving this kind of parsing problems than Go. Definitely these things can be done in Go. You can save it into an interface and have a cast and go through a list of possible alternatives, but the solutions are just easier in Haskell.
Right. So I'm assuming that in the sort of the next iteration of the product where you do have a separate sort of let's just go with the term sidecar for now, but you do have a separate collector, if you will, right? Then the constraint really becomes how fast can you show sort of the results of your analysis of your anomaly detections, right, in your own dashboard, right? Not how fast you can process or how fast you can get out of the way of a particular request, right? In the case of the middleware, right? So then would you say that it doesn't matter as much how fast the processing of the JSON is if you are collecting and maybe doing some compacting on the collector side, maybe doing some sampling right before the data even reaches the edge of your network? Would you say that the speed of processing JSON at that stage doesn't really matter?
So what we're doing actually, you can divide the problem that we're solving into two things. One is that we're building a model that represents the API. Mm-hmm. And the second thing is that we get a stream of APIs and we're comparing each item in this stream against this model. So this is kind of the validation process. Mm-hmm. So this working with this stream and comparing is what we're doing in Go. But building this model, which we're then going to compare against, is just what we're leveraging Haskell for. And processing the stream is where a lot of the anomaly detection happens, because you want to go through the traffic in real time, and if there's an issue, you want to alert someone. But in terms of building the model and displaying it on the dashboard, that's something that there's no real time constraints. There is a time constraint, but it's just more flexible. You don't need the most performance thing to display this model on a dashboard, for example. But you need the fastest thing you can get if you want to process. For example, if we have customers who are maybe doing a million requests per second, we need something that can actually process 1 million requests per second. Basically process it and compare it against the model and say, okay, is this request valid? Yes, then throw it away. Is this request valid? Yes, throw it away. Mm-hmm. Pretty much that.
Okay.
So the API toolkit is open and is like available open source on GitHub, right?
Right now,
what happened was
it's a business. The middleware, like the Go middleware, is on GitHub, but we are just slowly rolling things out. Actually, right now, it's API Toolkit is in a closed beta where we're testing with a few companies, and we're just going to gradually test with more companies on our waitlist. So, there's a waitlist, people can join. And, over time, as we're sure that we can handle whatever our customers throw at us, because if you think about it, we need to be able to handle the sum of the traffic from all our customers. So we have one customer making 1 million requests per second, another making 2 million requests per second. We need to be able to handle 3 million requests per second. So we just gradually making sure
Unless you
that we can
sample,
handle them.
unless you sample, baby, you gotta sample.
Yeah, that's a problem. I mean, we eventually would encourage sampling, but we need to be able to handle situations where there is no sampling. Because you never know where an issue would be, right? The issue could be in the request you sample out. So that should be a decision which the users of API Toolkit make for themselves.
Yeah, that sounds like a business decision. Kind of punt that down the road a little bit. Cool. So, given that the project has no open source components, right? How would you say the community can help you, if at all? Or is it not at the stage yet where you can get help from anybody?
Yeah, I think it's actually not so much at that stage yet. It's we are going to get to a point where we would need clients for most languages.
You need help with getting clients.
But that's not something. I mean, that's something that we would figure out when when each new language that we need a client for comes up. Yeah.
Okay, so the clients for languages, not customers' clients.
No. Clients. The collectors, precisely. I mean, customers, clients as customers, that is always welcome. No one says no to clients. But yeah.
Cool.
Fun. Okay.
Is it that time, Natalie?
It is. It is the time.
Here we go.
Time to invite Matt.
I actually think you should probably leave.
Okay, now that we have Matt Song with us, we can officially approach the second part of the show in the last 5 minutes. So, guys, we are interested in your unpopular opinions.
I know
Who
we
would
heard
like
some
to
from
go
Smile. Well, I don't think they're that unpopular. He raises some fair points. Don't send a null strings.
yeah,
no responses.
yeah.
Use the HTTP codes.
Use the HTTP codes.
Yeah, please always use the HTTP codes. They are there for a reason.
So, but what is your actual unpopular opinion?
Okay, it's not really API or tech related, but it's more of educational. It's more like I think the current school system, or the school system that's always been just doesn't work. You subject children to, like, I don't know, is it 8 hours, 10 hours in school with 15 to 30 minutes break, and they come back home to do 2 to 3 hours worth of homework. They're like bank workers, or no, it's like the kids are basically in this reform sweatshop that you pay for. That's how I see it. Yeah, you send your kids to a sweatshop and you pay for them to suffer, because I mean they're children. Okay, like you have a full-time job, you work like 8 hours. When you're done, you're tired mentally, you're stressed. Then imagine children having to go for like 8-10 hours outside their home. They come back and they have another 2 to 3 hours of assignments. They have no life besides school. Like we don't build children's character. So I really think the school system should be modified in a way. There are shorter times, focused learning. And I think there was a study where children who are homeschooled actually perform better than kids who actually go to the traditional education systems. So that's my unpopular opinion. I don't know.
Were you scarred by this growing up?
Oh yeah, I hated homework, to be very honest. I did it, but I hated it.
It's almost like we're training our children to go into some pre-existing system where they go to work 9 to 5
Yeah.
and
The rat race.
we're training workers, aren't we?
Yep. We are. We're training.
Yeah.
We're giving them. It's a stress test.
Yeah.
Can you handle what's gonna come for you after school?
Yeah.
Yeah.
All right. Well, I don't know if that's gonna be unpopular, man. That's you know. I don't disagree. I don't disagree. Yeah, I hear you.
I definitely agree. I think I saw a like a talk by somebody, sorry, I don't remember, a TED talk, and he was like kids who want to go into kindergarten get interviewed, and it's like,
Oh,
what exactly
wow.
are you interviewing these kids for? Like,
I
I
saw
used to
that
ask
talk.
them, what have you done with the 3 years of your life? Just breastfeeding.
I don't know.
So-
Pee, poo, try to walk around. I mean, I don't know.
Show me how you use the touch screen. How you open and close apps.
Yeah.
yeah.
Okay.
I think someone said something like, he saw an advert that said college begins at kindergarten. He was like,
Good
what?
Lord.
Kindergarten begins at kindergarten.
Yeah, I think it was that same talk.
Right. From Ken from TEDx.
Yeah, that guy.
Shout out to Ken from TEDx.
Anthony, what's your unpopular opinion?
Mine is just that I actually think German as a language is quite nice. I have been in Germany for 3 years and have been avoiding the language until this year. And after some months of classes, it just makes so much sense. The rules are so. I can't imagine learning English as if I didn't learn it as a child, because when I think of the rules in English, like there's almost no rules. There's exceptions of exceptions of exceptions, and in German it just makes sense. So yeah.
Okay. So you were for lack of a better term, you were afraid of it until you started learning it.
Yes. And I mean, there's this popular stereotype about the German language. It's like it's so machine, so harsh, so. But I mean, maybe that's also what makes it nice, because then the rules are very clear.
Mm-hmm.
Until you hit exceptions.
So
But there's probably less than in English. I think I would agree with that.
I hope. I'm still learning.
Yeah, well, let's see. So your unpopular opinion is that German is actually nice.
Yes.
Okay. I will be curious to see how is that going to vote out.
We'll see.
Nice.
Yes, you can think of it also as a sort of a contract, sort of an API.
My API contract with the German population. with the ladies at the Anmeldung office.
City registration and all the bureaucracy. It is a serious contract with them. They will not upgrade to version 2.
Yes, they would not.
Yeah.
Cool. All right. Well, thank you very much for joining. And thanks everybody who tuned in. And we'll look forward to hearing about your contracts with the world, I guess, and all the text.
Yeah, good luck.
Thanks for having us, guys.
Bye to our viewers.
Bye.
And